Alright, so in this video we're going to extend the technique that we used in the previous video to simplify radical expressions to simplifying radical expressions that include variables. So let's take the simplest of these expressions, the square root of x squared. And we know that based on the definition of square roots, the square root of x squared is just the quantity that when squared gives us x squared. And that should be fairly intuitive. The square root of x squared is just x. Another way of thinking about this is squaring a value and taking its square root are inverse operations of each other. So in the same way that addition and subtraction are inverse operations of each other and they cancel each other out, multiplication, division, same thing, exponentiation by 2 and taking a square root are inverse operations of each other. So this would cancel out the squaring of x. So let's take a slightly more complex version of this. Instead of squaring x, we're going to cube x. And using the same technique that we used in the previous video, we're going to factor x cubed into the product of some quantity squared and some quantity that's not squared. So we could factor x cubed into the product of x squared times x. And sure enough, x squared times x to the first is x to the 2 plus 1, which is x cubed. So that makes sense. And now we can use our multiplication property of radicals to simplify this expression. The square root of x squared, which is kind of like our perfect square, is just x. And the square root of x can't be simplified any further, so we're just going to leave it as the square root of x. So we can rewrite the square root of x cubed as the product of x times the square root of x. So let's take a slightly more complex expression. Let's take x to the 4th power. Now, I'm going to do this the long way, and then I'm going to show you a slightly more sophisticated way of looking at this problem. So the square root of x to the 4th can be factored into the product of x squared and another value. So that's x squared times, and we're going to get another x squared. So what do we do here? X squared times x squared equals x to the 4th. So what's the square root of x squared times itself? Well, we know the square root of x squared is just x. And we're going to multiply that by the square root of x. Sorry, the square root of x squared is just x. And the square root of x squared is another x. So that leaves us with x squared. And sure enough, the square root of x to the 4th power is x squared. And why? Because what happens when you take x squared and you square it? Well, we know from our power of a power property that x squared squared is just x to the 4th. So this definitely fits our definition of square roots. Now, we can approach this problem in a slightly more sophisticated way. Rather than writing this out the long way, we can just say that x to the 4th power equals the product of, and follow me here, we're going to say that this is going to be x squared squared, right? Because that's the same thing as x to the 4th, except I've written x to the 4th as a quantity squared. And what is that quantity? What's inside the parentheses? X squared. So the square root of x squared squared is just going to be x squared. And let's do one more. Let's do x to the 5th. And I'll show you two ways of doing this. X to the 5th can be factored into the product of x squared times x squared times x. And now, using the multiplication property of radicals, we can simplify this expression. The square root of x squared is x. And we're going to multiply that by the square root of another x squared. So that's going to be another x. And then the square root of x can't be simplified. So that's just going to be the square root of x. And so another way of writing this would be x squared times the square root of x. Now, a more sophisticated way of approaching this is to realize that you can factor x to the 5th into the product of a perfect square, or a quantity squared, and x. And how can we do that? Well, we already showed that x to the 4th is a quantity squared. x to the fourth times x would be another way of writing x to the fifth. So let's put x to the fifth there. The square root of x to the fifth power equals the square root of x to the fourth power times x. And we can just write x to the fourth power as a quantity squared. We know that that's just x squared squared. And so now we can take the square root of x squared squared, which is just x squared, and the square root of x is just the square root of x. And that's the basic idea of factoring, of simplifying radical expressions with variables in them. So now let's move on to some examples. All right, let's simplify the following radical expressions. Now you'll notice each one of these expressions has a numeric term and a term with a variable. So pause the video and attempt these three on your own, and then I'll go through them. Pause the video now. All right, let's see how you did. So here we have the square root of 72x cubed. So the first thing I'm going to do is I'm going to factor my numeric term and then the term with the variable. So 72 can be rewritten as the product of 36 and 2, or 36 times 2. And x cubed can be rewritten as the product of x squared and x. And notice I've factored my numeric term into the product of a quantity squared and 2, and my variable I've factored into the product of a quantity squared and x. So now I can take those quantity squareds and simplify them. The square root of 36 is just 6. The square root of x squared is just x. And what am I left with underneath the radical sign? I'm left with a 2 and an x. And so the square root of 72x cubed is the same thing as 6x times the square root of 2x. Let's see how you did on number 2. So I'm going to follow the same procedure. The square root of 50 times y to the fifth is going to be the square root of, and 50 is just 25, a quantity squared, times 2. And y to the fifth is just going to be x squared squared, which is just x to the fourth, times x. And that's going to leave us with the square root of 25 is 5. The square root of x squared squared is just x squared. And that leaves us with 2x under the radical sign. And then finally, number 3, the square root of 98x cubed y to the fourth is going to be the square root of 49 times 2 times x squared times x, which is the same thing as x cubed. And I'll do this one the long way because, this is a sophisticated way of writing x to the fourth, but it may confuse some of you. So instead of writing y to the fourth as y squared squared, I'm just going to write it as the product of y squared times itself, y squared. Now, how can we simplify this? All right, well, we know that 49 is a quantity squared. That's just 7. I should say the square root of 49 is 7. The square root of x squared is x. The square root of y squared is just y. And the square root of y squared, is just another y. So I'm left with 7xyy times the square root of 2x. And it's bad form to leave this expression like this. You don't leave two y's next to each other because we know that y times y is just y squared. So we'd rewrite this as 7xy squared times the square root of 2x.